welcome everyone. It's a pleasure to see you all. Before we get started, just a few housekeeping items. Each panelist will have about 8 minutes to present their information. And once Rich has completed, we will begin the live Q&A. Now, let's get started. Ulrich, please kick it off.
Yeah, thanks, Stephanie. So as I understood, you will bring on the presentation, right?
Yes, I believe it will be just showing.
Yeah,
Excellent.
I believe you. Yeah, so I could start a bit. Yeah, digital port twin. Yeah, I mean, I've been talking to many people of many different organizations about twins, digital twins, digital port twins, and the interesting thing is that nearly every person has a different opinion about what it is, and so I'm very happy that I could explain and what I think what it is. So if we would go on to the next slide, please. Yeah, so from our point of view, digital port twin is a complete digital image of different things. And the first is that we think all physical objects should be have a digital image. This is bridges, it's K-walls, it's the depth of the waters, roads, and so on. And not only the physical objects, but also the places where they are. So what we did, we brought the whole port as a digital image and placed the different physical objects. Another important thing are the processes, because the objects are interacting with each other within processes. Of course, we do not forget about the people, and we have systems and devices as well. So next slide, please. A digital twin consists from different modules. So one thing, of course, are 3D models. Yeah, so we have the 3D models, and we can visualize them with virtual and augmented reality. We have sensors. There's a little mistake in the presentation. So we have sensors with its data. We have simulations based on this data. And of course, we have data platforms, and the big question behind is to integrate it. So we are integrating these platforms in the cloud. So I brought examples for each of the modules. So if we would go on to the next slide, please. So first is sensors. Yeah, so you do not need to build new objects. You can also use sensors in old existing objects. For example, the Kölbrandbrücke, the Kölbrand Bridge. It's the biggest bridge in the port. It's 54 meters high, and we are on the way to make this bridge smart. So if we go to the next slide, we can see that the first thing we did is to have a digital twin. So on the right side, you see the real twin, and on the left and on the right, you see the digital twin. And if we go to the next one, we will see that due to the sensors we brought in the bridge, we use it for different reasons. One is, of course, predictive maintenance. Yeah, so you're measuring data on the time, for example, changes in the lanes or corrosion. Yeah, so you can see how it's like, and you can predict the future, and also real-time information. And exciting or an important information is ice, yeah, because in winter we have ice on the lanes, and this is of course dangerous for the driver. So this is an easy example that we bring the real-time information out of the sensors to the people that are using the bridge. If we go to the next slide, then we see the 3D models. Yeah, we have 3D models, and we want to use the 3D models with augmented reality in our maintenance. So one big job we're doing in Hamburg is measuring the depth of the water, because it's changing all the year due to the currents and the sediments that are on the ground. And these little ships here are going each day through the port and measuring the data. And on the next slide, we can see what we think where we could use augmented reality. So here you see, if you're on the bridge on the boat, you see where you're driving, and the little monitor in the middle is bringing up the information. You always, if you're the driver or the captain of the boat, you have to look at this monitor, and then on the out of the screens again. And on the next slide, you see that we are working on a EU founded project that's called Visit, and there we are bringing on information of the depth of the river, because we have the twin of the river itself. We know how deep it is. We have the 3D model, so we are working on it to bring the information straight to the captain. Next slide, please. And the next slide, you see, all right, you can all 3D models you have, you can of course bring with augmented reality, so you can give information to objects next to the ship. Next slide, please. One challenge at the moment we're having with augmented reality is that the boat is of course moving in all 3 dimensions, yeah. And if you do the tracking, it's not so easy to go with this. And so we are on the way to solve this, hopefully. And next slide, please. And another thing is collaboration. Yeah, so we are bringing the information not only to the captain, but also to people who work in the office and who are communicating with the captain, not only by video pictures or movies, but also by the information the captain is seeing himself. So it makes the communication between people in the offices and the captain out in the port much easier. Next, please. The next example should be virtual reality. Our use case for this is okay, that was fast, but it's fine. Example, our engineers, yeah, traditionally our engineers are planning the new buildings with paint, with pencil and papers. Then they came up with 2D models, and then you see it here. Yeah, you just can click on, thank you. And then you see in the end that we have the 3D models, and the 3D models are combined with data. That's the new thing. Just go on this slide, please. And you see that the 3D is combined with data like timetables or invested budget, or also the elements of the different objects. So what we did is we took this 3D models and brought them into the VR world of the port. So on the next slide, you see one of our engineers on the top right. You see they have VR working places now in their offices, and instead of going physically to a construction site, he can do it within the virtual reality. So on the next slide, you see that he's gone on a construction site. They're building a new bridge there, so you can see the bridge. And on the next slide, you can see that he is even able to see underneath the ground. Yeah, so this is an old log, for example, that is underneath the bridge. You see all the poles where they have been, and you can explain to third-party people what's going on, how difficult the building is, and how to go on with the job. Next slide, please. Yeah, this is just some screenshots of our virtual reality world. You can see our BTS center on the left. So if anybody want to visit our BTS center, he doesn't need to come to Hamburg anymore. You can also see it already in the VR world, our new bridge, and on the bottom right, you see that we also have the city of Hamburg within the virtual reality world. Yeah, this is the main station, for example. So it's not only working for the port, but also for the city. Next slide, please. Another thing, yeah, you remember in the beginning, I was talking about simulations. Yeah, this is the big topic for us, simulating things before building them. On the next slide, you see our idea behind this simulation. So the main thing for us is to have a strategic tool. And if we do plannings for big things like new terminals or changes on terminals, or building tunnels or bridges or stations or whatever, this of course has big impacts of the whole port, of the traffic, of air quality, of everything. And we want to simulate that before we build it. So last year we did this year, and it started last year. Yeah, we did a simulation tool for our cruise guests. Yeah, we have 3 cruise terminals in Hamburg, and we were analyzing the way of the cruise passengers, how they were coming from the main station towards the cruise terminal. And on the right, you see a kind of macro view. Yeah, you see the main station and the 3 terminals and the lanes in between. We're showing that we were analyzing how the tourists were coming with train, walking, taxi, or vans or whatever. And on the left, you can see that we were also simulating within the main station and also within the terminals what the tourists were doing. Yeah, so this is that was our first project, and using agent-based models for simulations. Next slide, please. Yeah, this is already the last slide. This is a look into the tool. Yeah, on the left you see the different parameters, so you can play around and say let's use more taxis, let's use more trains, and then you can see on the right. Yeah, it's hard to understand, but you can see a top view of the main station, and you can see the agents. The agents in this case are people that are walking around from the luggage station towards the buses, and then they go with the bus to the cruise terminal. And on the left, you see the graphs that are more or less analyzing the situation and to understand what kind of challenges you could change or solve. So if you go to the next slide. Yes, that was already it. And I showed, or what I wanted to show is that we have single solutions for simulations, for virtual augmented reality, for IoT, for collaboration. And the big challenge is now to integrate it. Yeah, so this is we are working on integration of all these different topics. So thank you. I hope that was within 8 minutes. I didn't have a clock here, so I hope it worked. Thank you, Stephanie, and thank you, guys.
Excellent. Thank you so much, Ulrich. We really appreciated that. Next up, we have Piet Opstaele. Take it over, Piet.
Stephanie, I think it's good to hear that this session is your favorite one, because I think the things were shown by Ulrich were really quite impressive. So I go, on my side, I go a little bit back in history and see where digital twins are coming from and how we see that in the Port of Antwerp. And the second topic, I think Ulrich focused a lot on simulation and VR. I will focus a little bit more on situational awareness. So actually, I think you see here a picture, a very nice one, which is almost 100 years old. It's the analog digital, it's an analog twin, it's not a digital one, of Antwerp, the city and the port during the World Expo in Antwerp. So you see at that moment already people feel that having a visualization at a certain scale, at a certain level, is very attractive. Next one, please. You don't have, we have also human digitals. They have an equal DNA. And here you see actually one of the two, and it's maybe hard to guess which one it is. I'm on the left side. So even for myself, it's sometimes hard. It's sometimes hard to see exactly who I am. It means that things can be very equal. Okay. Next one, please. So of course, technology has been evolving a lot in the last 20, 30 years. And our vision on this and digital twins, we build a concept on that, we call it APICA, is having a combination of the human intelligence with artificial and digital intelligence. I think we are only today at the beginning of a period where these two forms will become much more closer to each other and much more integrated, where the human has sight. We can use cameras, eye noses to smell what the air quality is in the port. So technology can really assist people in having a better view of what is currently happening in the port. Next one, please. So how does it look like? So we started 2 years ago, and actually 3 years ago, with some inspirational movies. But today we are at the stage of operational implementation of our digital twin, our digital nervous system. So the vision there is that we create a digital nervous system with all kinds of sensors to monitor what is happening actually in the port and create automatic alerts of certain incidents, of an accident, of an explosion, an intrusion. So not somebody who is looking to 20 screens and looking what is happening now. No, building an intelligent system where technology can assist people in having more focused view on what's happening in the port. Okay, next one, please. So just as a small intermezzo, and I think Uli has mentioned already several of these, what are the different dimensions you can see within a digital twin? And it's based on a model, a scoreboard built by McKinsey, and they distinguished 9 different dimensions of technical functionalities. It's all about data, and digital twins. If you don't have any data, and we talk about massive amounts of data, it doesn't work. So having that handling and analytics, I think it's great to see that artificial intelligence and data analytics is becoming more and more advanced to be able to handle these large amounts of data. The second big dimension is visualization, and that could be a simple 2D map, or some examples already shown, a more complex advanced 3D map. The third dimension is about situational awareness. What is happening now? Another one is about simulation and physical modeling. Right? If I do that, what is happening? And actually, digital twins were originating from that business. Back in the beginning of the 2000, they were built and started by simulation of machines to see what the specific behavior of machines can be. And ultimately, we end up at automated systems where work processes without human interference can be processed and provide information. Next one, please. So how have we translate that to the Port of Antwerp? And see, here you see our overall data architecture view. So on the left side, you have all the inputs, all kinds of sensors and data. It's about machine vision, it's about weather information, video information, radar, IS, drones. So we are building that infrastructure to build these data pipelines. In the middle, there you have the brains, the intelligence, where all the data real time is coming in, and also where your historical data is built up, and your analytics on top of that is created. And then, of course, you can visualize that in several different forms on a mobile phone, on your laptop, and so on. So if we see how what we did actually last year is defining use cases. Okay, that's good to have a good vision on this and an architecture, but what does it mean for the user? So what have we been doing in the first half of this year is collecting potential use cases for digital twin. And actually they are not all listed here, but we collected more than 120 potential use cases. And that's just amazing how big the potential is there. And you see a few big groups. It's about monitoring of air quality, water quality. It's about detection, for instance, detection of oil spill. It's about inspection of our maritime infrastructure. And it's about visualization and seeing where are the ships now today or current at this moment in the port. So what are we doing? Currently, we're building step by step these use cases into the system and come to one integrated system where our staff can use it. And we have a small movie on that.
Good morning and welcome back. General status report. Today is an overall sunny day, with a light breeze from the northwest. Port traffic is busy as usual at this time of day, with 221 barges and 180 seagoing vessels in port. We're expecting 95 new arrivals and 73 departures today. Road mobility is within efficiency norms. There are 2 INOS quality alerts and 1 ongoing event. Would you like to investigate? At 8:51, INOS 22 detected possible hazardous compounds. Analyzing. According to historic wind data and ship tracking, a possible cause might be the chemical tanker My Fair Lady. Would you like to collect an air sample? Please select available UAV. Calculating flight trajectory. ETA in 1 minute 30 seconds. Initiate. Confirmed. I am Apika. Welcome to the port of the future.
Great.
So this is a concept where we say, come to an integrated system where technology will assist you. So Stephanie, I hope you're a little bit impressed.
Very interesting. Yes, thank you very much, Piet. I was at Smart Piers, the event last year, and heard you speak. So it's fascinating to see how much progress that you've made. So we look forward to hearing more about that in the future. Now, on to our next session. Last but not least, a good friend of PTI's, Rich Ceci. Rich, take it away.
Hi, thank you very much. Can you bring the slides up? So I'm going to digress a bit from what you've heard from my two colleagues in terms of a use for digital twinning. So it's important to understand a little bit about my background because I'm going to be talking about projects. The projects here that we've done over the last 14 years or so, 16 years, back up please. Okay, so 3 projects, 3 sites, 4 projects, a total of about $1.7 billion worth of investment that has each one involving hundreds of millions of dollars of investment to create a new terminal or to renovate an old terminal. Now, next slide. The typical project life cycle includes a business case expectations that are drafted. What are we trying to accomplish? How much volume? How much investment? The layout of the land is considered. How big can I make the terminal? What kind of access does it have for railroads or for trucks or barges or whatever? And these layouts are debated many, many times. It's the most time-consuming, complicated part of the investment. A simulation of the layout, and this is a digital twin concept that is used to prove the feasibility and quantify the operational risks. In other words, to achieve the payback for the investors who are putting their money into the project, can I pay them back according to their expectations? A project plan is created, including performance metrics. How many ships, how many containers per week am I going to process? What kind of turn time will the trucks have? How long will it take to process a vessel? How big are the vessels, et cetera? The project execution phase typically lasts for 3 to 4 years. And while those projects are typically executing and they're moving earth and they're creating cement structures and all that kind of stuff, emulation models are typically created that derive from the same source as the model that was used to create the investment, and they will be used to validate the investment later on. And then after we launch, there's an emulation use for tuning and training and such. Next slide. So during the business case, we want to determine how much money do we need? What are the funding sources? What are their expectations for payback? Are there any land use restrictions, environmental issues or concerns? Volume expectations, both short and long term. Expansion options. If the investment goes well, what are my chances to expand the investment and make sure that it will be something that can grow? You're never going to have too much of a good thing. Staffing decisions. How many people will I have to employ? I heard on the previous session people asking questions about what impact major new terminals have on employment. That's certainly a major consideration. Technology risk assessments. What can go wrong when you start bolting together new things? They don't always play well together. And then a risk register, some way to keep a visibility on all these different risks through the life cycle of the project. Next slide. So when we consider layout options and simulations, these are debated and they're very important because the use of the land, when you get near the water, near an ocean, near a channel that can operate a large megaship, every piece of land, every piece of the area being developed becomes super critical in terms of what it can be used for and how it can leverage the investment. Environmental simulations are critical. Here in the Port of Virginia, for example, we have a very active modeling program that the local universities have taken on, where we can actually see the impacts of sea level rise. The Port of Virginia is second only to the Port of New Orleans in terms of risk relative to sea level rise in the United States. And so we spend a lot of time focusing on that. Also on things like the susceptibility to weather-induced flooding. For example, when we did the terminals up in New Jersey, as we were building the terminal, Hurricane Sandy hit the New York area, and we found not a 100-year flood risk, but a 500-year flood risk. We stopped the project for 6 months, re-engineered the heights of all the electrical enclosures based on that kind of feedback at a time when we could make that kind of a decision without hurting the port. Once the simulations are created, it's really the start of the digital twinning concept. Once the project plans are created, performance metrics are created, usually based on simulation results. So, for instance, if somebody's going to supply a crane, how fast can the crane operate? If somebody's going to supply a terminal operating system, what capability is it going to provide? These various guarantees, if you will, these various promises are very important. And sometimes they work their way into contracts with the suppliers that insist that their promises made during the bidding process, during the design process, are realized during the actual performance of when the project is finished. It's very important during this phase. I say this every time I make a presentation. It's managing the expectations of the stakeholders is the most important critical thing here. There's no use in starting a project knowing full well that you can't deliver what the promises are. And getting everybody on board before you start investing and building is a very key thing. Next slide. During the project execution phase, that's typically 3 to 4 years, and technology risks are validated. We make sure that assumptions are validated. We manage risk in 2 dimensions, schedule and cost. The emulation models that are created during this process really create what I would call the second phase of digital twin usage. These models can be used to train staff in the early phases, so we can teach people visually how they're going to use the system. They can also be used to do other things like, I got to make sure I see the slide. They allow for training of the testing of the software systems. When we first started here in 2007, there were no terminal operating systems that did this. They were all created by people that in Hamburg and in Rotterdam from scratch. They were all custom systems. We spent over a year and a half with a digital twin of the terminal, debugging the software that was going to be used to operate it once we turned the systems on. And finally, the mechanism to isolate performance of the multiple suppliers. When you start putting technology components together, you have to make sure that all the components work as promised. And this provides a good way to help isolate what's not living up to its standard. Next slide. Post-launch, so you've got this new $400 million terminal running, and what do you do with it? This is phase 3 of the digital twinning process. We used it for software quality assurance. In other words, testing new versions of the software. We use it for ongoing training, and we use it for software tuning, adjusting the software without having to take a problem out in the actual physical reality of the terminal. And then in the future, potentially operational shadowing. For simulation, we use vessel arrival patterns to plan yard usage, and over-the-road truck arrival patterns using road traffic simulations in order to predict how reliable truck arrivals will be. And that's been done with the cooperation of the local cities. So we know what their traffic patterns are like, and we can bring them in and make sure that when the truck leaves to take a container to a destination, we can predict how long it's going to take for that truck to do a turn and come back and get its next mission. Next. So what happened in 2004 to 2007? What were our expectations? That we would make a significant contribution to staff training. We did partially. The model of testing vehicles and driving vehicles was drastically underestimated. Remember, this was in 2007 now, and we didn't have Xbox, and we didn't have virtual reality goggles and all this kind of stuff. And so some of that in the early days just didn't match up to what we needed to have in order to make this effective. We did, however, achieve a very good level of control room training so we could simulate what was happening and put people in scenarios that would allow them to react properly. We expected that TOS would reduce the startup issues related to terminal operating systems. We got significant results from this. This was 18 months worth of testing against a simulated model of the system. 75 major bugs were discovered and fixed during that period of time. The terminal startup was completed in 4 months. It was actually 3 months ahead of schedule. We started doing 22 moves per hour on a ship, on a crane. We ended up at 35 moves an hour in only 4 months' time. And we went on to achieve 45 moves per hour, which is a world-class performance. And then we get down to the operational shadowing, which we had prepared, and that didn't work at all. And sadly, I think that's an area for the future. But the software was too complex. The speed of the system was too great. There were too many bugs in the software, and the algorithms took too long to calculate and produce results. By the time we modeled them, the event was past. So that never really came online. Next. In 2020, what are we doing? We are using the model, the emulation for staff training. It's useful, but with the terminal built, we find that it's actually better to do some of the training on the job in the terminal. But we have done a number of supplier-led gaming scenarios where we put teams of people against each other, running against the model terminal to see who can operate it the best. That's turned out to be very good. We still use it for testing software upgrades. Extensive use. We're able to achieve major software upgrades with minimized bugs, no crashes, things are very smooth. And that's because of the twinning that we're using to test everything. Emulation and operational shadowing, still very elusive, but we're getting to a point now where the software is becoming more stable, and we're actually back into looking at this as we speak. Next slide. Simulation is expanding. We're seeing predictive cargo logistics patterns for vessels, trains, and trucks are happening. We're looking at forecasting our volumes by day as much as a month out, so we know what to plan for. We're seeing changes in volume by shipper or consignee. So for example, here in the United States, everybody wants to know what Walmart needs, and we're able to predict that kind of traffic flow better. We're also starting to use more artificial intelligence. Depending on who you talk to, I saw Piet's presentation here. Artificial intelligence is an important component, and it relies on a lot of the same process knowledge in order to achieve accuracy as a digital twin does. And finally, we think that by combining the digital twin model with advanced learning, we can significantly improve the operating efficiency of the port. Next slide. I think that's it. That's it.
Rich, we really appreciate that. It was very interesting to see your step-by-step journey. Thank you for explaining all of that. Now we have time for a few questions. Rich touched upon this in his presentation, but I'd like to ask the two ports that are here with us today, which are, what are the two key, most important things for ports and terminals to consider when embarking on a digital twin? Uli, could you please start us off?
Yeah, I mean, I think you should not wait for a big concept and plan everything, but I think you should have a vision in mind, and then you should simply start. Yeah, I think so. The first and most important thing is start with let's say with islands, and think about integration later on. So I think this is the two things. One is not to do, and the other thing is just start away. And another thing, of course, is don't do it on your own. Do it with the stakeholder, with the people, with the companies around you. Yeah, so if you do it on your own, I think you are lost.
Great. Thank you. Piet, any wise words from Antwerp?
Yeah, I fully agree with Uli, but also be sure that from the beginning you have a clear view on your architecture, so that you really build a system with small steps, but at the end that you have something which is an integrated system, that you don't have isolated functionalities all around. So I think that's crucial to have that. And also don't forget the user. I think Rich also mentioned that. It's important to take, it's not a technical discussion, it's important to take the user with you, because at the end, these are the people who has to use the system.
Great. Rich, anything that you'd care to add?
I think the most important thing, if it depends on how much money you're spending. You know, if this is a small investment, I think there'll be a lot of patience. But just be careful who's funding this and what their goals are, what they think you're going to achieve, and try and make sure that you deliver, because you want to make sure that people don't get disappointed with the technology during its embryonic phase. It takes time for these things to work, and it's helpful to celebrate the the wins, as opposed to be disappointed because you didn't do something, extremely extravagant. So take small steps first and get everybody happy and on board with the technology.
Great. Thank you very much, gentlemen. The final question for me today is, where do you see smart ports in 5 years thanks to the digital twin? Let's start with Piet.
Yeah, I think we need to build these data pipelines. We need to add that functionality, come to that integrated system, and with the fast evolvement and development of data analytics and AI around that, I think magic will happen within 3 to 5 years. If you have enough data, if you have enough functionalities, then you can do all kind of crazy combinations. Look what the weather impact is on your port operation. So do really advanced analytics and build that intelligence into your system and have really that system approach. I think if we can realize that within 5 years, we have done a good job.
Great, thank you. And Uli, what would you say?
Yeah, first, what Piet says, I'm fully with that. I agree 100%. And I think all the smart ports, or the ports which are already smart right now, and will get smarter. This is one thing. And the other thing is the connection between the ports. Yeah, I'm pretty sure that within 3 or 5 years, we will have connected twins, and also the ship owners and the trucks, the trucking, the logistic companies, they will be integrated in the whole system. So I think we will have a complete digital connected system of the whole supply chain with the ports in between it at big hubs.
Great. Rich, over to you.
Well, from a port perspective, I think there's several technologies that are starting to evolve that are going to have a huge impact. One of them is 5G, because we think that's going to be a major factor in terms of allowing things to communicate fast and reliably without a lot of wiring, and it'll be very dynamic. And the other is the increased use of autonomous vehicles. We think that as autonomous vehicles start to enter the mechanism, we're going to see a more reliable way of communicating data between, or communicating cargo between the different modes, between vessels and warehouses and things like that. And I think being able to model that technology and model those behaviors and react properly, that's a really key aspect in implementing autonomous vehicles. It's being able to recognize, essentially in a digital twin mode, what's happening in the real world.
Great. Thank you very much, gentlemen. We have actually one question from the audience with regards to cybersecurity and cyber attacks. And the question is, can you simulate a cyber attack with a digital twin in order to, I guess, stress test the IT systems? Ulrich, are you able to answer that?
So I wouldn't, I try my best,
Okay.
so I wouldn't say I wouldn't give too many insight, because cyber resilience, cyber security is a big topic, but it's a real good question. Yeah, I mean, you have to be able to simulate stuff like that. And if you think about digital twins, I mean, the good things, we were talking about the good things, but on the other side, we also have risk. I mean, the more systems, the more sensors you have, the more you are open for cyber attacks. So you have to be really good in cyber resilience, and you also need simulations to do that.
Great. Anything that you'd care to add, Rich?
Well, they need to come back tomorrow morning and hear me talk on this. I'll be doing another session then on this topic. So this is a commercial for tomorrow's session. But it's certainly, the more technology to use, the greater the chances are that a disruption hurts you. The risk profile goes up almost linearly with the amount of technology employed. So I agree with Uli on that.
Great. And final words from Piet.
Yeah, it will be a never-ending war. So go to the war with the right weapons, and don't forget the people, because in a lot of cases the weakest link is user behavior. So also there, spend your time and focus on training people in how they should behave when they are active on connected systems.
Excellent. Well, thank you very much, gentlemen, for your time, and we look forward to seeing some of you tomorrow. To our audience, in case you've missed any part of this session, please check out the Smartport TV platform. Thank you for joining us.